Welcome to Basic Electronics lecture series. I, Professor Hitesh Dolakia, is going to explain you ideal diode and practical diode approximations in this video. So first I'll explain you how we have ideal diode approximation. So for that one should have basic understanding regarding diode. Let me tell you that, see, when you keep diode in forward bias condition, at the time diode should be on, and when you keep diode under reverse bias condition, at the time diode should be off, right? So that is how diode should function. Now in ideal diode you will be observing that it is perfectly functioning like a switch, in that if you keep diode under forward bias condition, switch will be on. So as switch is on, one can say potential across diode is 0 and infinite current is passing through the diode, right? And when diode is there under reverse bias condition, at that time it offers open circuit, or one can say open switch. So in that case one can say there is infinite resistance, so 0 current will flow through diode, right? So this is a first approximation, that is referred as ideal diode approximation. You can see in its characteristics, in reverse bias there is 0 current, and in forward bias infinite current is flowing even though you increase voltage little bit in forward bias, right? Now let us talk about second approximation. Now see, in second approximation we consider diode in terms of silicon or germanium. Now if I consider diode as silicon material, in that case you will be observing diode is working as a switch, but in series with that there will be a battery due to potential barrier, and for silicon there will be 0.7 voltage, right? So battery along with switch is the approximation which is there with second approximation. So you will be observing that after 0.7 voltage in forward bias there will be infinite current flow, right? But in reverse bias that open circuit is there with switch, so it offers infinite resistance which does not allow flow of current in reverse bias. So this is second approximation. You can see that here in characteristics, right? So that characteristic explains what? To turn on diode you'll have to give greater than potential barrier. For silicon it is 0.7 voltage, and in reverse bias it is working as open circuit. Now let us have third approximation. Now in third approximation we will be having a resistance of diode as well as battery and switch. So equivalent circuit of diode will be like switch, battery and resistance, right? Now there will be forward resistance when you have forward bias condition. So when you have forward bias condition you will have to give greater than potential barrier voltage, then only there will be flow of current. For silicon you will have to give greater than 0.7 voltage. If you give greater than 0.7 voltage, then that circuit will be considered as switch on, and if it is that case, in that case after 0.7 voltage there will be flow of current, but that current will be having a slope which is based on resistance, right? So there will be little inclined line that you can see in characteristics during forward bias condition. Here you can see in characteristics in forward bias condition 0 to 0.7 voltage, 0 current is flowing. Greater than 0.7 voltage current is flowing, but it is increasing linearly as per resistance which is approximated. In reverse bias condition diode is considered with open circuit, and with open circuit infinite resistance is been considered, so 0 current will flow. So there are three approximations. One is ideal diode, which is having a characteristic like in forward bias condition infinite current will flow, in reverse bias condition zero current will flow, right? In second approximation, we consider diode as a switch in series with battery. For silicon, it is 0.7 voltage. In third approximation, we consider diode as a switch in series with battery of 0.7 voltage in case of silicon, in series with forward resistance RB, right? So that is how approximations are there, and based on these approximations only we consider working of our any circuit in basic electronics, analog electronics, power electronics, right? So one should know these basic approximations. I hope you have understood this. Thank you so much for watching this video. If you have further any doubts, you just place that in comment box. I'll be happy to help you.